In this session, we are going to discuss about the arc of contact. In previous session, we have seen the path of contact. The diagram for arc of contact is very important. So why? First of all, let us go through the diagram. In this diagram, we have got a pinion which is driver, a wheel which is driven. So the pinion is rotating in clockwise sense with angular velocity omega a. Hence, the wheel or the driven gear will rotate in anti-clockwise sense. Now, the three circles that I have drawn over here are the addendum circle, pitch circle and dedendum circle for pinion, and same I have drawn over here for the wheel or gear. So we do know that
the contact between two profiles is made when the line of action cuts the addendum circle of the wheel, that is at point C.
and the contact between two teeth breaks where the line of action cuts the
Addendum circle of pinion.
So the contact breaks at point D, which is the point of intersection
of the addendum circle of pinion and the line of action.
Now the angle made by line of action with the common tangent is phi. We have already seen it in previous session. So in triangle APF, the angle made at point P, that is angle APF, will be 90 minus phi. Hence, the angle PAF, this angle is phi. Now, let us consider the profile is involute for the pinion as well as gear. So I am going to draw the position of this involute profile at the start of engagement, that is at point C. So when the profile is at point C, it is as shown. So I have drawn over the involute tooth over here like this. So let us consider this profile is named as GH when the contact between two teeth starts. Now the same profile when moves to the pitch point, the position of this profile is as shown, and the involute at that instant is shown by JK. When the contact between two tooth profile breaks, let the profile is shown like this, and we are going to name it as DL. So DL, at this particular instant, the contact will break. Now the position of GH, JK and DL are very important in order to understand the arc of contact. So the GH involute cuts the pitch circle of pinion at point P dash, let it be P dash. At JK, the profile breaks the or intersect the pitch circle of pinion at point P, and at the end of engagement, the profile cuts the pitch circle at point P double dash. So this P dash, P double dash, this total arc traced by this point P on the pitch circle of pinion, or you can consider the same concept on wheel also. So this distance P dash, P double dash is called as the arc of contact. So what is arc of contact? It is the distance travelled by a point on either pitch circles of the two wheels, means pinion or gear, during the period of contact of a pair of teeth. So we want to find out the relation or the equation for this arc of contact. So arc of contact has got two parts. The arc P dash P is called as arc of approach, and the arc P double dash is called as the arc of recess. Now first of all we are going to find out the arc of approach. So for that, let us consider T suffix A is the time required to move the point from P dash to P. So this is the time to traverse the arc of approach. Now we do know that velocity is equals to displacement upon time, or if we want to find out the displacement is equals to the velocity into time. So in this case, what is the displacement? Displacement is the arc of approach, that is distance P dash P. So we can write arc of approach is equals to velocity. Means which velocity? So the velocity at point P, or the linear velocity at point P dash. So velocity at point P dash into time. So what is the time? So the time is TA that we have assumed. So velocity at point P dash, it is nothing but the tangential velocity. So tangential velocity or the linear velocity, we do know it is given by formula V is equals to R into omega. So we have considered the pinion. Let us assume its radius of pitch circle, that is AP or A dash P dash or A P double dash. This distance is small r. So the velocity, tangential velocity at point P dash will be r, that is the distance between A P dash point into its angular velocity. Its angular velocity is omega A. So the velocity at point P dash, or this tangential velocity, will be r into omega A into time. Time is TA, which is the time of approach. Now instead of r omega, I will write this as r into omega A into cos phi into TA upon cos phi. So I have multiplied and divided the above term by cos phi. Now what is r cos phi from this figure? So if you see triangle APF, in triangle APF, the AP side is r, the angle at point A is phi. So obviously AF will be r cos phi. So the r cos phi distance will be AF. So we are going to get what? The arc of approach will be equals to r cos phi into omega a into Ta upon cos phi. So r cos phi is the distance AF into omega a. So distance into the angular velocity is the linear or tangential velocity. But the distance is now what? AF. So which tangential velocity we are going to get? We are going to get the tangential velocity of point F or of point H. So we are going to get the tangential velocity on the dedendum or base circle. Okay. So r cos phi into omega a will be either the velocity of point F or H or K or L. So we will consider this as the velocity of point H. So the equation we can write as the tangential or linear tangential velocity of point H into Ta upon cos phi. So tangential velocity of point H into Ta. So tangential velocity of point H into the time required for the point to move from P dash to P double dash, that is to cover the arc of approach. So in time Ta, if point P dash is moving to P, the point H will move from H to K. So the tangential velocity V into T, so the velocity into time, this product is what? A distance. So what is the distance covered when the arc is moved from GH to JK? It is the distance HK. So the tangential velocity of point H into Ta will be arc HK upon cos phi. So I will rewrite this arc HK as arc FK minus arc FH divided by cos phi. So arc FK minus arc FH, we will get arc HK. The profile used in this case is involute. We do know the involute is the path trace or arc traced by the end of a taut cord which is unwounded from a circle. So if we are going to consider a taut cord is unwounded from this circle, then if I am going to unwound the piece of end or the end cord from point K, it will take the position P, right? So arc FK distance will be same as that of FP. So if I am going to unwound the cord from H, the cord will get a straight position FC. So FC and distance FH will be same. So arc FK is nothing but the distance FP, and arc FH is nothing but the distance FC divided by cos phi. So what is FP minus FC? It is the distance CP divided by cos phi. So what is distance CP? As we have discussed it in previous session, distance CP is nothing but the path of approach. So path of approach upon cos phi is nothing but the arc of approach. Similarly, we need to find out the arc of recess. So for that, consider the time required to move the profile from JK or from point P to P double dash as T suffix R, and follow the same steps that I have followed and tell me the answer.